So this was sort of the question, which is okay. So we're giving this figure. So there's two intersecting circles. So the information is that there's two intersecting circles, and the points of intersection are x and y. Then we choose two arbitrary points a and b. So I just chose these two, and we draw a line from x through from a through x to intersect the other circle. So that's at M, and then from M through Y to intersect the first circle at D, and similarly from B to Y to N to X to C. So from A to X to M, and from M to Y to D, and similarly from C to X to N, from B to Y to N, and from N through X to C. And we're asked to prove that this AB line is parallel to the CD line. No, I so I couldn't do it because I don't know. I'm not very good, but the so what I tried, the first approach that I tried was to look at these triangles ABP and NMP, and then try to prove them similar. And if I could prove them similar, I think I can. And then we would just have this NM, which would be parallel to AB, and using the same logic, which we prove AB parallel to MN, we could then choose MN as our arbitrary points and then have CD as the reflected points, which would mean that MN would be parallel to CD, so AB would be parallel to CD. So this was the most simplest approach I could think of, but I couldn't prove them similar. I tried think some things in my head, which did not work out. The other approach I had was even stupid, I prefer. So that approach was to basically, like, so if we just consider one of these points, let's say we just consider A, right? AX, and we just consider this pair, right? Now what happens if we move this point? So as A moves over this circle, the complete circle, so does M. So if A moves this side, then M must move this side, and they both complete one circle in the exact time whatever. So if you move, you basically sweep the same angle. So as A sweeps theta, M will also sweep theta is the hypothesis. And if we prove that the AB parallel to CD for one given arrangement of A and B, then we could sort of use something like induction, almost like induction, not really induction, but sort of on the idea of induction. So we could shift A with an angle of d theta, and then M would also sweep the same angle d theta, and we would use that the previous AB was parallel to CD to somehow prove this d theta shifted AB is also parallel to the d theta shifted whatever. So, but I mean, this could work out. Obviously, both of the methods I described would work out if you could arrange them in equations and stuff. But I didn't really try them because it felt very, very complex. So I looked at their book solution, and yeah, my methods were too complex. So here is their solution. So you basically join A and D. So let me just draw a line here. Just draw a line here, right? And I begin with angle this DAB angle, right? So this angle is subtended by this arc BD. So then, or if you look at DYB, it's subtended in the same arc by the same chord. So this angle would be equal to that one. And so this angle with these are two intersecting lines. So this would be this angle, and then similarly M and N subtend this Y, so this NYM would be the same as this MXN because they're in the same arc, they're subtended by the chord in the same arc. And similarly this would be equal to this because they're two intersecting lines. And then this is subtended by AC in this arc, so would the ACD. So this angle would be equal to this angle. So one, this equals this equals this equals this equals this equals this basically. And then finally these are alternate interior angles of AB and CD in this line. So if this angle equal to this angle, then AB parallel to CD. So that's a very clean solution. But if you want to, I am going to, but I don't know if I can. But if you want to, you can try doing the same thing in the methods that I describe if you can. I mean, because I can't.